No, they won't. So here I've got a bicycle, and I'm doing the 7% tax. We know that 7% is out of 100%. So if I have $1, how much do I pay, Rachel? If I have $1, how much tax am I going to pay at 7%?
7.
Josh?
7 pennies.
7 pennies. And I would write that as 0.07. This is where tax comes from. Tax isn't based on, it's actually not 7% of that, although it works out to be that way. It's actually 7% on a dollar. This is where tax, they base everything off from a dollar. So if you go and you stay in a hotel, there's a lodging tax inside of I think it's 4.5% or something like that. Okay? And so they're saying for every dollar, you're going to pay 4.5% more. So that means for $8, okay, I'm going to pay 4.5% on one, 4.5% on the second dollar, 4.5% on the third dollar, and so on and so on and so on. So in the end, it works out to be, I'm going to pay 7% on that whole thing, or 4.5%. So here, if I know this, what do we call this right now?
Fraction.
It's a fraction. Good. What else is it? Ooh. It's a rate. It's a ratio. Yeah. If I calculate this, I'm going to get a rate of 7%. This is a ratio. So if I have dollars down here, and I have, that's a dollar. That's dollars. This is tax. Now, here's my bicycle. Where would that go? In tax or dollars?
Oh, dollars.
Okay, now, check this out. Now you're going to know why you do what you do. So ready, Vanessa? This is a proportion. I do not know how much tax I pay on the bicycle yet, do I? But I do know this. I pay 7 cents for every dollar. So that means at this amount, I'm going to pay some tax. Do you see a scale factor here? Anything times 1 is itself, right? So this is 45.90. That's my rate from here to here. So what's my rate from here to here? 45.90. And what do I do with my rate? I multiply it by the one I know. So in order to calculate tax, I'm going to take my dollars and I'm going to multiply it by my tax, which here is 7%. How much tax do I pay on that bicycle? $3.21. Not bad. So Vanessa, you understand that? What I want you to really get, guys, Allie, is that tax is based on a dollar. It's based on 1. This is literally what they're doing. It's a proportion. It says, hey, for $1 you pay that much. Whoa, how much do you pay for this? Well, it's that proportion. That's literally where they come up with it. That's how it works. And that's why the scale factor is always this. So that's why you always take that and multiply it by your tax to get how much you pay. Ping! Okay, I'm going to give you 2 more minutes to... show me the fingers. Who needs more time on this? Okay, 2 more minutes. Go. If you don't need more time, okay, I want you to get together and start comparing your homework on the sides. If you don't need time, go to the sides, start comparing your homework. This is you, isn't it? And you know what I like? I like how you made the comparison.
What about Yeah, no, I told her.
So I kind of messed up on this. I did these two, but I forgot
There's two more.
Because
Yeah?
yeah.
Did you finish your homework? You're getting that tax done? Okay.
Okay, so now you need to do the math for each one.
I did the math wrong, but I got credit. I mean, like, I did the wrong technique.
No, I'm not saying. Ooh, I see what you did. Yeah, that actually works. But you see how it's not as efficient.
Yeah.
But it works. I know. Yeah.
After doing all the makeup work I had for Mr. Get's class for the past week, I was kind of spaced out, so I just kind of forgot about everything.
How did you know? How did you know it was 1 out of 35? Because what do we call that? I know it's a fraction, but it's the reciprocal of the equivalent scale factor that you found. Yes. Okay. That's good. Took the reciprocal and did it that way.
Anthony didn't do his homework.
Shh, hey.
What's my dog?
You don't need to make side comments either. Are we all good here? Okay. Yeah? Elise, are we good here? Andrew, did you do your homework? You forgot to do D. Javier? Yeah. This is, right? It's like 75 cents is my unit rate, and we're going to multiply it by my cost? That makes no sense.
They're both the same units. They're both the cost.
No, it makes no sense.
I need to start bringing a calculator on the floor with me. I can't see Mr. And the guy's name was Jesus.
Okay. Are we pretty good over here? All right. Head back to your seats, guys. They're good over here. All right. So I want to talk to you about D, and then I'm going to let you guys go, which is going to be cool because I'm going to give you literally 35 minutes of independent team time. So Lucius and Javier, I want to go over this one because I know in previous classes it created a lot of misunderstanding. Lucius, they discuss how to write an equation relating to the price and the number of songs. Lucius writes this. He says, hey, number of songs times 75, because that's how much, what is that called?
Unit rate.
The unit rate. That's how much each song costs. And then he's like, hey, multiply that by the cost, and that will give you your number. And then Javier says, well, actually, it should be the unit rate times the number is going to give you your cost. So which one's right? Talk to your partner.
I think it's Javier because
I already talked to you.
if you were
Yeah, why? Which one's right?
I said Javier because you're trying to find the cost and you want the cost into the equation. Doesn't make sense. So to find the cost, which is what
He'll find me. He'll find me. It kind of gets an attitude.
you need to figure out, you need to multiply the price per song to the number of songs.
So it's all about angles, man. Sylvie made a great point. Sylvie was saying, she goes, wait a minute. I wouldn't take my unit rate, which is a cost, right? Cost per song, and multiply it by my cost. That doesn't make any sense, okay, to find my number. But I would, and Elise said, I would take my unit rate, multiply by how many songs I'm going to buy, and figure out how much I'm going to pay. So Javier is the one who, he got that right. He nailed that. All right, today, this is your work for today. We have A1. It's been doing this when I go to this slide. It's very interesting.
It's haunted.
I don't know what it is, but it's been doing it every time. So you have A1, A2, A3, A4, and A5. We are going to do a 10-minute workshop around one other question. Okay? But these are the ones that I want you to work on today. I'll be going around. This is what I'd like to see today. Is that when you go to talk to your partner, don't ask them, what did you get? Don't make it a comparison of numbers. Ask them this. Explain to me how you did that problem. You'll get to the answer. I want to know the process, and I want you to share your process. It's a way deeper conversation to have about the process than it is about the answer. Because we're all going to solve things different ways at times. Just like Allie's way to solve the 75 cents. That was impressive. That's a very difficult way. Because you got it. All right. You know where it is. It's 2.3.
I got a question. A comment.
Your T-shirt does not.
I was gonna say.
Excuse me.
Is that right?
Okay. So you tell me. What are they asking you to find, Quinn? The unit rate of what?
How much one?
Okay. So they want to know how much one orange costs. So I have two numbers, right? I can have my numbers this way, 10 over 2, or I can have them this way. What does this help me find? What unit rate does this help me find? Okay, so this is going to be oranges per dollar. This is going to tell me dollars per orange. Which one am I trying to find? Dollars per orange. You can use a calculator today. I know, it's freedom. Freedom! But you see, I can flip it. It means a different thing, right? Very different relationship.
Is that right?
Well, you tell
That
me.
doesn't make any sense.
Okay, yeah. So you found 5 oranges per dollar. Great! Cool. Is that what they're asking you?
No.
They don't want to know. They don't want to know how many oranges per dollar. They want to know how many dollars per.
Orange.
So what do I have to do this ratio?
Flip it.
I gotta flip it. So then I have a relationship of dollars per orange.
I would do like 5. You can use a calculator.
Can I?
Mr. Mick?
You ever heard of a 0.2 cost for an orange?
20 per.
Ah, I've heard of that. Just saying. Boy, we're done.
Well, I heard you over there, and I thought I was very confused. Because we thought we were doing this year. And I'm like,
Or no, that was yesterday.
I like that.
So, have you ever heard of Pay me 0.2. Good. Right? I know that's a minor thing, but when you think about does my answer make sense, you should say, oh, wait a minute. Right? Okay.
Give me 2 cents on the dollar for that.
That'd be the cheapest orange on earth.
How come they're so outrageous?
Yeah, so the first time around, what did you find?
I found
Oranges per dollar, which is useful, right? If I have $1 in my pocket, I'm like, hey, how many oranges can I buy?
like first find one way and then do it the other way.
Good practice.
Then when they ask,
Oh, what is?
And you're like, I know that.
Come back here. I can't.
Come on, Andrew.
I can't. Isn't it the one paper that we were doing yesterday with the pizza names on it?
Yeah, it's very similar to that, right? So what's question 1 asking you to find?
What is the cost per orange?
Cost per orange. So when you hear that cost per orange, it's literally cost per orange. So what's my cost? Hold on. What's my cost?
$2 for 10.
So, here you go.
What?
So fill in the ratio. What's my cost?
$2
Okay.
to 10.
Okay. What does that equal?
Like dividing it? 5.
You tell me.
$0.004.
Try it again. Something was up.
0.2.
So if I get an answer here of 0.2, what does that mean?
That there's $2.
0.2. What were the variables here?
$2
And 10, right? What were the units that went with them?
cost oranges.
So what does that 0.2 mean? It means 0.2
Oranges
per.
$1? No. $2?
It means $0.2
Per
orange per orange. Because whatever's on my bottom, when I do my unit rate, that comes out of 1. Right? It's based on 1. So it's cost, which is dollars per orange. Is that what I'm trying to find? How much one orange is?
Yeah.
So what does that mean, 0.2?
That it's 2 cents per.
You're close. Not 2 cents. 2 cents is this. That's 2 cents.
20 cents.
Yes, and you have to put the 0 on the end. Good work. Okay, you got to remember, it all depends on which way. If I put the 10 on top and the 2 on bottom, that means oranges per dollar. In that question, it's not asking me how many oranges I can buy for $1. It says how much is one orange. That means oranges have to go on bottom, dollars have to go on top. So what is that, 0.2? It's not 2 cents. It's 0.2.
Is
2
it-
cents is 0.02.
Oh.
So what's 0.2?
20.
20 cents. Yep.
Yeah. 20 cents times 5 is what? 20, how many?
Right, and now you got to do the reciprocal, right? So it's 1/10 times 2. Nice work, Rachel.
One orange.
So
So now we
I pay 0.2.
one orange.
What's 0.2?
10 cents.
There we go.
We know one.
Got to put another 0 on there. I know that's what the calculator spits out, but you got to use common sense to be like, how much is that?
You're on
I like your equivalent ratios.
Me?
So yeah, what's 0.2 mean?
$0.2 per orange.
So what's $0.2?
$4.
Well, what is 0.2 in dollars?
20.
Because 2 cents would be 0.02. So you need to make that look like 20 cents. Because it's not 0.2 or, right? Yes. Okay. I know the calculator spits out 0.2. Then you have to say, does that make sense? No. But 20 cents makes sense.
20 cents makes sense.
That was good. I know. Thank you.
Camera's still whirling.
She just keeps being.
Camera's still on. It's still recording.
I know.
Oh, you do?
Josh is ruining the video.
I thought you didn't know that.
You ever heard of 0.2?
Cents.
So you're telling me that every orange is 2 cents.
Yes.
So, how many oranges can I buy for $10? I mean for $2. How many oranges can I buy? Look at your chart. It tells you. How many oranges can I buy for $2?
10.
So, if they're 2 cents a piece, is 10 oranges going to cost me $2?
No. No.
So hold on, you need to think about what that 0.2 means.
Then oranges would be.
So if they were 0.2 a piece, they were 2 cents a piece, how much would 10 oranges cost?
$6.
Well, let's see. One is 2 cents. How much is 2?
4.
How much is 3?
6.
Okay, so right there, we're at 10 cents, and how many oranges have I bought?
5.
So if I bought 10 oranges, not 5 oranges, 10 oranges, how much would I pay?
10 or 20.
20 cents. But wait a minute, you know that's not true. 10 oranges cost $2. So what does that 0.2 mean? You see how I'm trying to make sense? It's like I know 10 oranges cost 2. So it's impossible that 1 orange costs 2 cents. And Josh, 2 cents is written like this. So how much does 1 orange cost?
20.
So when you get 0.2 on a calculator, when you're talking about money, you have to put a 0 at the end.
I did not know that.
Okay. That's why calculators aren't that great, because they're not always going to give you the right answer, especially when they're talking about dollars and cents. You need to know what to put on the end.
I feel like it might not.
That's right. Well, tell me, how can you check that?
Go back to
Yeah? And so how much does 10 oranges cost? So, can you check to see if I have 10 oranges, can I check to see if that's going to equal $2? How would I do that? Could I make a table? Right, I could go 1 orange is how much? 2 oranges is? So you could do it that way, right? And then you could be like, okay, is that right? So, but I know how many oranges is $2? 10. What's 10 times? Okay, there you go. Times 0.2. That's how you check it. Yeah.
So for A, what does this equation tell you about the relationship between the number of oranges and the cost of oranges? So C means cost, right?
Mm-hmm.
B means oranges, but it doesn't give us the number of oranges.
Right, so what does this equation tell you about the relationship between the number of oranges and the cost of oranges? So if the cost goes up, what happens to the number?
It goes down.
Well, you tell me. If cost keeps going up, let's say I put a 1 in. $1
It's
cost.
going to go up.
So as cost goes up, so does
The oranges.
the number of oranges. If cost goes down,
So does the oranges.
that would be,
But it doesn't make sense because there's 5 cents for 0 oranges.
that doesn't mean 5 cents. It means 5 what?
$5?
Yeah.
Maybe you have to put in the many of.
We don't know exactly what that means, but here they're asking to look at this. And here, that's, as cost goes up, as I take cost, if it goes up, well, anything times 5 is going to make the n go way up.
So 5 times like 2, the n. So the oranges.
And then it's going to be 10. The number's going to be 10. Right?
The orange. So
If I spend $2, how many oranges do I buy?
10.
Is that true right here?
Yes.
Yes.
Yeah.
Does that make sense? You don't know where that 5 came from, do you?
Yeah.
So I could tell that's what you're like. Why isn't it 0.2, right? Because that's how much 1 orange is. Instead of telling you how much 1 orange is, it's saying how much.
10 oranges.
No, a bundle or $1 worth, which is 5. That's what they're doing there. It's a kind of confusing question. Just keep working with it though, as best you can, and keep asking for help. I'll come by.
Do you want me to get a different piece of paper for a graph?
No, A6 isn't up there. I know, you just get in that mode, huh? Like chewing up math. I love it.
I'm confused about C. Wait.
Yeah, identify 2 unit rates from the equation.
Wait, it's not C, there's
So, yeah, it says 2. What are the 2 unit rates that they're giving you in the equation? What are the rates? Rates would be, what were the 2 rates?
oranges to dollars.
Oranges to dollars, and what's the other rate? Dollars to oranges. There you go. Bam! Good work. Those are rates. Right? And they're making that comparison. Hey guys, I'm going to ask you just one question so you understand something. So, question 5C, this is what I've been going over in every class. Yeah, 5C. Okay. These right now are just fractions. Right? But as soon as I put labels to them, what do they become? Ratios, which are rates. So, this is oranges, and this is dollars. This is dollars, this is oranges. Now they're no longer fractions. They are ratios. It's a comparison, it's a relationship. So what is this rate that I'm trying to find here? Yeah.
How many oranges you get for $1?
Oranges per dollar. That is this rate. And that is, and literally it's written the exact same way. Oranges per $1. So what's this rate down here, Anthony? No. If this is that rate, what's this rate? Dollars per one orange. These are different rates. And they can help me. I just need to know which one to use in the right time. Okay, we're going to do, like I told you, it's about a 10-minute workshop. Sai, can you help me out? Will you grab graph paper and give each group one piece?
Oh, how many groups are there?
Just grab a stack and then put whatever's back.
I have graph.
Carl, you're going to work with Rachel. Okay. Anthony, you're going to join Olive. Okay. Your job right now is to go to A6. And this is our, Chris, this is our independent think time. I'm going to give you about 45 seconds to read A6. And I want you to start thinking about your background knowledge. What do I know about this problem? Don't try to solve it. Don't try to overthink it. Just think, what do I know about what they're asking me? Not on the graph paper, just in your head. So, 45 seconds. Go ahead, read it. And think to yourself, what do I know? Thank you, Simon. Okay, hit right here. Read that question. I appreciate that. A6.
Equations from question
No, hold on,
five.
you have to.
No talking yet, just reading, just thinking. What do I know? A6. Okay, we know that this equation is true, and it gives us to us cost equals our unit rate times our number, which is quantity, how many we get to buy. We know that this is true. This is what I want you to do on the back side of the graph paper. You have 1 minute. Fast and furious. What do you know about this problem? Don't try to solve it. Tell me, what do you know? Go. What do you know? Hey, Josh, work with Allie. What do you know? Right. On the back. What do you know? What do you know? Right.
I know we're supposed to graph it.
Write it down. Graph. These can be bullets. They don't need to be sentences.
Use questions 5 through 20.
Oh, I have someone. Someone wrote down graph. What do you know about a graph? Get more specific. Dig into a graph. What do you know about a graph?
I said 5 questions, 1 graph.
Put it down.
Graph paper.
What do you know about a graph?
5, and then
Nice. What do you know?
They scale like big.
What do you know about a graph? Doesn't need to be sentences. Can be bullets. Make it quicker.
so n equals the cost.
That it's a value of 1 to 20.
What do you know about? What do you know about X and Y?
I don't know anything about that.
No, I think it's not then.
Oh, that's the bottom.
What else do you know about a graph?
I don't know.
Ben, what do you know about a graph?
Help us define the unit, right?
You can. All right. Okay, here we go. So this is what you have an opportunity to do now. So I'm going to be trying this today to see how it works because I really enjoy this. I learned about it when I went to my conference. if you feel like you are stuck, you can get up and do what we call a gallery walk. I can walk around and I can look. I can't talk to them because they're a picture. They can talk to each other, but I can't talk to them. I can talk to my partner because they're not part of the gallery. If you're not stuck, you're working. And you're talking with your partner. You are not talking to gallery walkers. Okay? You get to walk the gallery one time. That's it. So you have to figure out when's a good time to walk. Like, when am I so stuck I can't work anymore? I can't make progress. That's when I can walk and look with my partner and say, oh my goodness, you see what they're doing? That guy, blah, 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 blah. They're doing this. I think that's what we need to do.
So basically we're allowed to copy their work.
Not copy their work. You're allowed to have a discussion about what they're doing to get unstuck. They're not going to talk to you at all. You got to figure out what they're doing.
But you're allowed to look at their paper.
Andrew, yes, you're allowed to look at their paper. There are no answers on this, really. Yeah.
How many walks
You get one.
a day or a week?
No, you get one walk during the session. Okay? Does that make sense? You get to walk the gallery one time today. That is it.
Only today?
Yeah, and you only have 5 minutes. You have about 6-7 minutes. So, ready? Get going. Solve A6. This is that whole idea of like productive struggle. Like, you have to know, like, I have worked so hard now. Now is the time I need to go look to see if I can't get scaffolding. Yeah, what's up?
Sorry, but I don't like it. I don't either.
I still like you, though.
Yeah.
Hey, I'm just going to tell you. Be careful with this guy. He's a tight.
Yeah, it's this.
How can you graph the unit rate?
So do I need to make like an L?
Is that what you do in a graph? Does that look like a coordinate plane? Josh, does that look like a coordinate plane? Making an L. Work with Allie. Work with Allie.
I don't know what that looks like.
Yes.
Okay, so what would
Because that's a graph.
Okay, come on. Start getting it.
you can use the
Yeah, now start plotting it. Oh, nice.
I don't know what you're doing. Good job. Right now.
Tell me about those numbers you're putting down there. What do they represent?
Dollars. These are going to be the cost, and this is going to be the amount of oranges we have. So we'll do like for every 5 oranges, it's going to cost $1.
So what happens if I buy one orange?
like you won't.
Might want to think about it.
Now we have to go like 20 cents. I have no idea. So
I didn't say that.
Should we do
From 1 to 20, so we just go like.
But that might be a good idea. So tell me about your numbers here. What do those numbers mean?
Those are the numbers of the ones.
The amount of oranges and the size.
Okay. So, right, can't buy half an orange. That makes sense, right? So tell me about your numbers you're going to put on this axis here.
Well, you have to figure out the cost of them first.
Which is 20 cents.
Okay. All right. Okay. Start working on your other axis. That's plenty far enough. Hey guys, I was just taking a gallery walk, and I can tell you that Anthony and Olive's picture, their gallery, what they're making is pretty awesome. It's great scaffolding, maybe. But remember, you can't talk to them. You can talk to your partner.
Do your work, Mr.
We'll revisit that question on Monday.
We're kind of confused.
So you think you're getting stuck a little bit?
I don't think we ever.
Really? What's the confusion?
Well,
So what values of n? That would be what?
Yeah, that's
Okay, but what does n represent?
number of the
Okay, all right. So I wasn't even talking. I didn't give you anything. Good, awesome.
Yeah, Miss.
Let's go. So back.
What if it says two? We have to graph.
So you guys have cost,
We finished.
and then this is number of oranges.
Yeah.
And is this right?
Wow.
It's kind of hard to see. The numbers are small.
You like writing small.
Sometimes I write big.
And then sometimes I write small. No, this is excellent.
Sweet.
I like how. Did you guys make a choice about why you put which one on which axis?
It just kind of made.
Or was that okay?
I mean, I see how you could go either way, but
It can't, truly.
Would it make more sense to like have the numbers on the bottom and like see the price for the oranges instead of having the price?
So in science, you call this the independent variable, and this is the dependent variable. The reason why this is dependent is because this depends on how many of these I buy. Right? If I buy 8, then so that's called the dependent, and that's the independent, and that's how they always are. Right? It's like dependent always on the y-axis. Okay, guys, go ahead. We will continue some of this work on Monday. Please put this away. Okay, and get your exit ticket out.
Alright, now we're gonna go.
All right. So Anthony, thank you. As you are cleaning up, Jay, as you're cleaning up, just have your voice off and have your ears open, please. So, good work. I was impressed. That was a good work session from you guys around thinking about how do I tackle this problem of showing this relationship on a graph. Because we know that with an equation, because an equation, it's going to look like this. It's going to be the cost times our unit rate, which was 20 cents, times the number of oranges. So this is a good equation that represents a relationship. This is the equation that represents our unit rate. Graphing it is another way to show a relationship, and it's a really important one. If you think about how often you open up the newspaper or you open up a magazine or you're watching the news and they put a graph on there. You get persuaded by graphs all the time. So understanding how they work is really important. Your exit ticket is this. I'm not going to show it because I bit way too much off today with trying to do an exit ticket. It's going to be, and you're going to pass this in, what is a unit rate? And give me an example of a unit rate. Go. What is a unit rate? Okay? And give me an example of a unit rate. We're passing those in. So make sure your name is on it. Okay, right here. All right, Jay, you're good to go, bud. Have a good weekend.
You too.